Okay, so we're here to talk about, on the first of the panel discussions, about next generation array architectures. So we know we've got lots of issues in storage that we're still dealing with, and that could be scale, such as dealing with big data. It could be dealing with virtualization and the consequent increase in IOPS. And obviously there's new technology out there, and there's things that are being put into new technology that's allowing us to do that. So on, yeah, sure. Okay, so on the panel we have, and if everybody's starting from this end, I'd just like to very quickly introduce themselves. Starting with yourself, Jason, and then everybody knows who you are. Obviously your name's at the front so people can see that, but just give us a brief 10-second description of yourself and why you're on this panel.
Great, so I'm Jason Collier. I'm the CTO and founder of a company called Scale Computing. And for the last 3.5 years, we've been selling scale-out storage architectures, really focused more on mid-market companies. But then I've also kind of integrated some virtualization stacks in there as well. So virtualization and scaling those storage requirements are something near and dear to my heart.
Okay.
I'm Dave Wright. I'm the founder and CEO of SolidFire. We are selling an all solid-state scale-out storage system for large cloud computing environments.
I'm Tom Isakovich, founder and CEO with Nimbus Data. We are a developer of multi-protocol flash memory storage systems.
I'm Matt Kixmoeller. I'm the VP of Products at Pure Storage, and we're also a developer of all-flash storage systems.
I'm Robin Harris, and I am not a developer of all-flash storage systems.
So Robin,
I'm in the
this
confirmation bias business.
So is the non-vendor on the panel. Would you like to start discussing some of the issues that you see out there? You talked about them a few minutes ago, but people might not have just seen your presentation. They might have just tuned in now. So maybe you can highlight some of the issues out there, things like the big data issues, some of the virtualization and so on.
Well, one of the issues that really I find interesting, and I'd love to get comments on, is basically we're rapidly coming to the end of the days of easy wins, because for the last 3 years you've been able to compare your all-flash arrays to disk arrays, which is like shooting fish in a barrel, right? I mean, disks are slow, they're hot, they take up a lot of space. Flash is fast and cool, but now there's a fair number of flash arrays out there, and I think the competition is heating up, and I'd love to get people's comments about, are you still finding yourselves comparing your devices to your arrays to disk arrays, or are you starting to compete with each other?
So who wants to start by saying they've got the easiest job in the world by selling us an all-flash array then?
I guess I'll start with the first comment. We're still, from our experience anyway, very, very underpenetrated in the market. And if you look at just the whole space of all-flash arrays, we as a vendor community have been talking about it for a while, but almost all of our sales go to customers who started out thinking they just needed to replace their disk array. And we come in and teach them that all-flash is an option they should look at. And but that's still the vast, that's a minority at this point. We are starting to see some head-to-head POCs against our competition. I'd say maybe 20% of our end customer deployments are kind of head-to-head with other flash vendors. And I'd say there that one of the biggest things that people have realized, unfortunately, is a lot of the datasheet claims don't always match with the reality of the customer. And that's partially because of idealized environments on the datasheets, and that's partially because not all apps are the same. And so really what we try to tell customers is you should absolutely look and test and do your homework and do a POC, and we welcome that. And there's ultimately no better way to find out how your application will really perform on Flash.
Yeah, it still is predominantly the disk array vendors. We're increasingly seeing the kind of the tiering and the caching type arrays where a customer is potentially weighing a flash accelerated NetApp against an all-flash solution from us. In some cases, they're weighing PCIe flash against us and trying to look at ways to potentially leverage PCIe instead of a traditional shared storage infrastructure. A lot of times those customers are coming back and saying, this distributed storage model is just way too complex, and they prefer going to the SAN and NAS model. The other piece that we're starting to see too, a little bit of, is kind of just the diversity of the environments. One of the things that we do is we support SAN, NAS, InfiniBand, everything, and many customers come to us and say, well, it must mostly be fiber channel, right? And actually we have almost an even split across all protocols and all interconnect types when we engage with customers. So about third of our business is fiber, about a third of it's InfiniBand, about a third of it's Ethernet. So it's a pretty interesting environment, but still for the most part it's the disk array vendors, you know, the NetApps and EMCs, the 3PARs, things like that we're up against.
Yeah, I think the other important thing is a lot of people try to put all of the all-flash vendors in a single bucket and say, okay, there's disk storage and then there's all-flash storage as a kind of single market. And the reality is that you know, the different markets that the flash vendors are selling to, in many cases, there's a broad array of applications and use cases for those flash storage, from folks that are targeting the extremely high-end performance scenarios to folks that are more mid-range focused, to the place that SolidFire is focused, which is really very large-scale cloud deployments. And in that space, there really aren't other flash solutions that have the same level of scale and performance that we have, and so we end up competing primarily against the disk-based vendors. And I would say that's true in almost all of those segments, is that the reason that, you know, there is not quite as much competition around flash array vendors as would probably be perceived from the number of companies out there, is that they have done a pretty good job of segmenting themselves and targeting different markets and different opportunities, because flash really can address a lot of different segments of the storage space.
As the only disk-based vendor up here, it's a yeah. So I mean, really, we
Thanks, Howard.
we see it as it's a market, though. I mean, like I said, we really go after mid-market companies, and you know, typically the areas where we're going in and competing, flash is not necessary. It's like for basically SMB and mid-market companies, that's like taking a Ferrari to go pick up the groceries, when a Toyota Corolla does just fine at picking them up. So really it's application driven for us, and basically the applications we focus on being those mid-market, we see really not much demand for flash. Do we have it running? It's running in the lab. We've not had a single customer ever ask for it. So that's where we are.
What are the other types of competitors that we are seeing now every now and then are these integrated application appliances? This notion of just doing the entire thing with an Oracle Exadata, let's just plop that thing in there, or doing the whole thing with a FlexPod or VCE or that kind of a device. And we're emphasizing to the customer that there's a value in being able to scale compute and storage independently. And they quickly realize that, especially when they look at the price tag of a lot of these proprietary solutions that it only does one thing in a very limited way. But that is another competitor besides just the classic standalone disk array vendors.
The industry is pushing people in the direction of saying, though, that we should go for these hybrid solutions. But by the sounds of it, you're saying we shouldn't do that. There's still a lot of mileage to have separate components and put best of breed together.
I think so. I mean, I think maybe in the SMB space where complexity is a big challenge, you know, the Swiss Army knife is appealing. But when we talk to, you know, mid-sized enterprise, even small enterprises that are growing very rapidly, and certainly in the service provider space, you know, they definitely are thinking that part of their value proposition is actually the architecture expertise to choose best-in-class compute, best-in-class networking, best-in-class storage, wrap it together, rather than pay kind of a margined up appliance that ties them to a single solution.
I see that that's really basically the guys that like to do it yourselfers, like you said, in the enterprise. Those are the guys that really do have that expertise. They've got the SAN expert, they've got the server expert, they've got the virtualization experts, all working together because they're a large enterprise. And I think that whole converged piece, which is, you know, effectively what we do now, integrating servers, storage, and virtualization all into basically one component, but it works very well in that mid-market because they don't have the expertise. There's like 0 to 5 IT guys that manage the infrastructure, and for them, there are several ways you can, you know, build a car. You can go out, you can get the wheels, you can get a transmission, you can buy an engine, or you can go out and buy a Toyota Corolla. We're selling a Toyota Corolla. And if you want a Ferrari, we got Corollas. I mean, that's basically what the difference is. So when you do have, I mean, then there are very specifically, you know, those applications, especially in the enterprise, where you need to fine-tune your infrastructure to run basically that application that needs to be run. In the mid-market, it's not so much, there's not as much that kind of thing. They need to run Exchange, they need to run SQL, they need to run SharePoint. And that's really what you find in those smaller mid-market sized companies.
So, Jason, are you hoping that Ferrari are watching this today?
I'm giving them a lot of plugs.
They're going to send you a free product or something.
When I was just over in the UK doing product launch, and then ours was the Mini Cooper when I was over there.
Right.
So,
Okay, so
you know,
just
you'll
for
appreciate
the theatre,
that.
yeah.
You know.
So, Davis, do you think there's anything that Flash can't solve? Because it seems that flash is the
Yeah.
answer to everything. so
Yeah, no,
far.
I think
All our
that,
issues.
realistically, the storage world is moving into a place where you have a capacity optimized set of applications and set of storage, and a performance optimized set of applications and storage. And we're seeing in the market two different approaches to that. One is trying to build do-it-all storage systems that have disk and flash together and can do the capacity and can do the performance and magically optimize for both of those things. And then the other approach, which is to build purpose-built capacity optimized storage system, object storage and scale out object storage, things like CleverSafe and Nirvanix and Scality are great examples of that. And then purpose-built performance storage like SolidFire. That allow you to offer a range of performance levels out of the same storage system depending on what the applications need. So particularly in a cloud or a service provider environment, you can sell one customer the Corolla, and you can sell another customer the Ferrari, and you can do all of that within the same storage system because it has support for a wide range of performance, but it's still flash-based. And so I think there is going to be both of those things. The kind of overriding question is it all going to be in one box, or are you going to have optimized purpose-built systems? And I think part of it comes to the question of scale. The very small scales at the SMB level and the small enterprise level, having a one box that does everything and does a decent job of it makes sense. But when you get to the larger and larger scales, that's where the efficiencies and the optimization of having purpose-built systems for capacity, purpose-built storage systems for primary storage and for performance storage make a lot of sense.
So Robin, would you agree then that you think the market is fragmenting? We're not seeing a small number of general purpose devices. We're seeing people coming at the market from a different angle to solve people's problems.
Well, clearly there's growing niches, and I think the flash vendors are finding their way, into those niches with various architectures. To me, it's really interesting the extent to which, some people are saying, hey, let's just do basically a fairly regular, RAID array, but, replace it with SSDs. Other people are taking a higher level architectural approach where they say, hey, let's take a bunch of SSDs and then figure out a layer software on top of those. I think Pure Storage does that. To create the functionality that people need. But you look at the world of Wall Street high frequency trading, those guys don't care how much they spend for storage. If they need to spend $1 million and they can shave a couple of a few milliseconds or microseconds off of their execution times, they're totally there. They don't care. But that's not, and that's a big enough business that there's some companies that are going to be very successful doing that. But that's not everybody. And I think Dave's point about capacity versus performance optimized storage is really critical. There's a huge demand for ultra high capacity storage today, and flash is never going to meet that requirement because it just costs too much. And disks are actually pretty good at large files, and in a lot of these applications that are data intensive, the files are large. So media and entertainment and genomics and geophysical, those are all large file environments, and using a flash as a cache makes good sense, but you're not going to replace everything, all the storage with flash. It's just too expensive.
So what other challenges do we think that are out there? So we've seen flash cover a lot of the discussion we've just had, and we talked about big data, and you talked a little bit about object there. Does anybody want to come in and talk about how they see the object market going and the technologies that are coming out there?
Well, I have a question.
Go ahead.
I'd like to ask these guys.
Go ahead, Robert.
These guys are in the trenches. As you're dealing with people that have been using disk-based architectures, are you seeing application bottlenecks and configuration bottlenecks that your much faster flash storage is exposing for the first time to these customers? And if you are, how does the customer take that? I mean, frequently don't like being told that their stuff sucks. So,
I'll jump into that one. I think it's an important question. And I think one of the challenges that had Flash off to a little bit of a slow start to begin with was many of the first Flash models were very disruptive. You know, you look at, for example, Fusion IO, and the pitch there was often great. We can offer you terrific performance if you go and redo your entire application architecture to be able to take advantage of this. And so you've seen adoption of, say, PCIe Flash in a very small number of customers who have the ability and the expertise to be willing to throw everything out and redo their application for it. Most enterprises aren't like that. And so when we've gone in, we've kind of gone in and tried to sell with a model that says, look, unplug your old inefficient array, plug in our array. You'll get enough of a benefit right away to be able to pay for that expenditure and that transition. But you probably are going to hit an application bottleneck. And then once that first transition happens, then we'll work with you to go and kind of tune your application and think about how to evolve your architecture slowly over time to be taking better advantage of Flash. But putting that re-architecture step right up front just stalls deployments. And so we've had to find a way to fit Flash into their existing architecture, show real benefit, and then show them a path for evolution towards improving the application.
Anybody else like to comment on that one?
The comment that I would make there is actually, if you look at where the bottlenecks are showing up with the Flash, there certainly can be bottlenecks on the application side, but I think a lot of what we're seeing and looking specifically at next generation Flash architectures is the fact that Flash is exposing bottlenecks in storage system architectures as well. And legacy storage vendors that are trying to put Flash in their arrays are finding themselves very limited with the performance that they can get out of it. The Flash is much faster than the capability of the array to deliver that performance. And the functionality that they're trying to layer on top of that Flash, they just can't keep up. Things like compression, deduplication, they can't do anywhere near the speed of that Flash. And the traditional array architecture of a single controller or a dual controller sitting in front of a relatively large number of disks is just never going to work with Flash. There is just too much performance, too many IOPS, too much bandwidth in those Flash drives for that model to work. And so, we certainly are strong believers in the scale-out model for storage architectures, but particularly the need for scale-out storage when you get to Flash, because if you can't scale out your CPU, if you can't scale out your memory, if you can't scale out your storage system network interconnects as you add more Flash capacity, you're not going to be able to get the benefit of that performance. That controller is just going to become too much of a bottleneck.
Yeah.
I've got a perfect example of just real quickly what Dave's talking about in a real customer environment. We've been in a POC recently for a very large analytics company, and that company is a big array vendor customer, and so they basically had to bring in the largest array that was out there, and they filled it completely with Flash. And this is literally an $8 or $9 million array that at the standard 80% discount becomes a $2-ish million array. And that array basically was put up against our little Flash box, and we beat it on performance, and we were 10x less cost. And so you just look at that and say, take the same Flash drives. If you don't really design the architecture to be centered around the Flash, no amount of retrofitting really gets the job done, and the inefficiencies are just glaringly obvious.
To add to that, the application piece is the key too as well. I mean, on both what we're saying about with basically Flash and standard disk, and then also scale up versus scale out. When you look at a lot of the enterprise applications that are running out there, they were built to run in basically a scale up disk environment. And when you inject either one of those, like scale out or basically Flash into that, you're not necessarily going to get the best performance out of the application because it wasn't written for the architecture. That's like if Google had went in and said, okay, we're going to use like a big EMC array, and we're not going to scale it past that. Just going to obviously ridiculous when you think about trying to push as many total IOs and performance in a system like that. So, but the reason that works for them is because it was written for basically a scale-out style of environment. So we're not going to see any real proliferation, I don't think, into the enterprise of the scale-out pieces until the applications for enterprise start being written the way they're supposed to be written to take advantage of those architectures. But I think that's definitely a trend in where it's going.
So that sounds like it's a bit of a chicken and egg then.
Well,
How does the application change
Exactly.
if the technology isn't
Yeah,
working?
and I think the way you address that is particularly if you look at how we use scale out and the applications and markets we're going after. It's not necessarily about, our system can do millions of IOPS. It's not about delivering millions of IOPS to a single application because most applications can't take advantage of that today, even if you could deliver it to them. And the applications that could, there's probably specialized storage architectures that do a better job on that than we do. What we really look at is In a cloud environment, the challenge is not one application that needs 1 million IOPS, it's 1,000 applications that each need 1,000 IOPS. And how can you scale out the capacity and performance for those applications and deliver that performance to them consistently without having them run all over each other, regardless of how many IOPS you can actually do. And that's really where we focused.
So I think we've got a question.
Yeah, I was going to say, given what you said, I mean, there was a lot of talk about the application side and the storage side. Given what you were just saying, does that also mean that potentially uncovering bottlenecks in the hypervisor, in the CNA, or in the network that's connecting the shared storage onto the servers?
Yeah, no, absolutely. I mean, we have seen that. I mean, VMware, I think, has actually done a pretty good job if you look at their track record over the last couple of releases of improving their storage performance. If you looked at how many IOPS they could do a couple of releases ago to now, you know, it's tremendous, the scaling. I think they've demonstrated 1 million IOPS now in VMware on a flash-based system. So they've had significant improvement there, and they've had to keep up with the advancements that are having on the storage system side. On the networking side, again, we're seeing big changes to the way networks are being built to add east-west bandwidth, because historically networks were built for north-south bandwidth, and when you have virtualization and you have storage networks on the Ethernet, you have to build the network differently to get the latency and get the bandwidth you need between those pieces. So there are changes that are going on in other parts of the ecosystem to make this all, you know, work together.
Yeah, there's also just inefficiencies, though, in traditional architectures that Flash actually helps mitigate. So while deploying a Flash solution may expose other bottlenecks, one of the bottlenecks is oftentimes CPU on the application server. And a lot of times those CPU resources are hung up, utilized in effect, and unable to do other operations because they're actually waiting for storage. You know, these I/O wait cycles can crank up CPU utilization, not really because the CPU is overburdened, but because the storage is not responding to the CPU quickly enough to actually allow the CPU to do what it does best. So what we've seen actually in some cases is, while you put in a flash storage system, first of all, storage is so far behind that putting in the flash storage system immediately boosts performance. But we've also seen an additional benefit where the actual CPU utilization of the application server actually goes down, even though performance actually goes up. And a lot of that goes through the elimination of these wait processes that can occur when you have a spindle-based array that's taken quite a while to respond to the I/O.
Yeah. I think we've got another question.
Yeah, so, excuse me, yeah. So, yeah, VMware can push 1 million IOPS to a single port, but that isn't where VMware systems typically run into problems. It's where you're trying to access the storage to multiple ports and trying to push more than that amount of storage, especially in VDI configurations. So, one of the things that you haven't talked about at all is what type of internal bus architectures you use in your flash storage arrays that actually are capable of handling the amount of storage that you talked about, and how you do port aggregation across your outbound ports to handle more storage, more IOPS, that type of thing. And I haven't heard any discussion about that at all.
Okay.
Yeah.
So I think,
talk
just to
about
summarise, in case that wasn't clear, I think what you're asking for is a bit of understanding about the underlying architectures that drive that particular throughput and how that's been changed within the devices.
Right, and
So-
I mean, one of the ways that different flash storage vendors can differentiate themselves is by explaining some of the bus architectures they're using to support the amount of I/O that they're trying to push through. And also, are you doing anything special on your outbound ports to handle multi-packet traffic like Nimbus or Isakovich do with their multi-packet configuration?
Right, so who's presenting the next couple of days? Because it's probably worth watching, because you'll see that, I'm sure, in the next couple of days if any of the guys are presenting. Or if you go back and look at some of the technologies, and obviously we've only got about 15 minutes, but Matt, do you want to give us maybe a flavour of some of the things that are in your technology?
So from our perspective, we're an active array. We use InfiniBand on the back end to connect the controllers. InfiniBand would have been overkill if our goal was to stop at 2 controllers. And so, you design for future expansion in that sense. And the same on the front side of the ports. Part of being, if you look at a lot of traditional array architectures, a lot of what you did in a traditional array was basically break up the array into lots of little arrays inside to guarantee these spindles get these ports, get this controller, and you almost create a little separate array to isolate performance. And that whole process goes out the window in a flash array because you really don't have to worry about performance contention of the back-end devices. You have a plentiful number of IOPS. And so it's much more of a flat architecture where different things can share. And then you get into some of the workload management inside to make sure you worry about the noisy neighbor and et cetera. And you'll probably hear more about that from folks like Dave.
But with the size storage you're talking about, it wouldn't be the flash devices themselves that you have attention on, it would be the bus inside the box.
Yeah, so one of the things we do that's different, and we've applied for a couple of patents on this, and what we call our parallel memory architecture, is instead of having a traditional shared SAS bus internally, which is what virtually every storage array for the last 5-6 years has done, they have basically a single chip SAS expander that all the drives connect to, and the expander arbitrates I/O across all the slots. Now that architecture sort of bets the farm that no drive is capable of actually driving line rate simultaneously. So this arbitration, this oversubscription is viable. And that's true in a disk array. But in an all-flash system, it just takes 2 or 3 flash drives to flood that expander. So that approach just has to go out the window. And so what we did in our architecture is a parallel architecture where it still leverages SAS, because SAS is a robust, hot swappable protocol that's very proven, but it's a point-to-point switched architecture internally. So every single flash drive has a discrete 6 gig connection into the CPU, into the PCI Express Gen 3 architecture internally. And what that does is it actually multiplies the bandwidth between the flash storage and the controller by about 6x. In a traditional disk array, it's only around 24 gigs. In our design, it's actually 144 gigs of bandwidth between 24 flash drives and a controller. Now, that would be for naught if you didn't also provide a way to actually access that 144 gigs on the outside. So we do that too. Actually, we do a little better. We do 160 gigs on the outside, allowing a customer to aggregate 4 ports of 40 gig Ethernet, or 16 ports of 10 gig Ethernet, or 4 ports of FDR 56 gig InfiniBand. So you've got this kind of 50-50 weight distribution, so you can get a full pass-through of all that bandwidth without any oversubscription, totally non-blocking. And that's a unique hardware engineering feat that we've done with our design for that exact thing you're talking about.
So, I think that's an interesting contrast to SolidFire's approach, because we've taken a very different approach, which is rather than try to take a single controller and try to put as many front-end ports and as many back-end ports on it as possible, which is essentially what you have to do with Flash, because they will saturate you if you have a small number of ports on either end. What we've done with our scale-out architecture is, take essentially one x86 server, put only 10 SSDs in it, so enough that we're not, we can put enough SAS channels in there to address those 10 SSDs. Put 2 10 gig Ethernet ports out the back, so again, enough that we can serve the I/O that those SSDs are doing, and then cluster those systems together over 10 gigabit Ethernet and make it transparent to the outside world. And then what we do is we distribute, and this may have been what you were referring to in terms of Nimble or EqualLogic using iSCSI, to distribute the front-end connections across that entire cluster over those 10 gigabit connections, and distribute them in such a way that we can balance the I/O across it very, very evenly. And as you add nodes to this scale-out cluster, redistribute the data, redistribute the connections to allow you to continue to scale the I/O. And we think that's the only way that you can get to a linear scalability of performance with a flash-based system, because otherwise there will be some point when you can't add any more back-end ports, you can't add any more front-end ports to that controller, and you can hit that limit pretty quickly when it comes to flash devices, because again, these devices these days can easily fill up a 3 gig SATA or a 6 gig SAS or SATA port very easily. So a true scale-out architecture where every time you add a node to the system, you're getting more front-end bandwidth, more back-end bandwidth, and you can distribute those connections across that pool is the only way to continually scale that performance.
So is the distribution engine something that you supply, or is that in the host?
We do that completely transparently. So it sees a single iSCSI endpoint, but in reality, its connections are being spread across the entire cluster.
Well, one other quick thing I'd throw on, just to change the thinking a little bit as well, is in modern arrays, many of the original arrays, there was very much a one-for-one relationship. IOs that come in the front door have to get pushed down out the back door to the disks in some way, and there's usually cache in between, but fundamentally that's fairly even. In a modern array, deduping compression dramatically changed that. So front-end IO does not one-for-one or one for more than one get pushed down to the back even with RAID. And there's generally some system that coalesces many IOs and finds a way to distribute evenly on the back end that's usually not directly hitting a single disk or a single set of disks or a single shelf. And so the better the array is at kind of managing that and kind of being smart about pushing the I/O on the back end, the less that linear relationship matters.
Okay, but I mean, it's still a single controllers or some pool controllers that need some shared knowledge to make that happen. And, so, I mean, a follow-up question just is, I haven't heard anybody mention PNFS. Is that anything that?
Yes. So I know you work for VMware, so I will say please add PNFS support, because PNFS solves some of the scaling challenges with NFS. NFS as a protocol is very limited in its ability to take advantage of these scale-out architectures because of its kind of single point design. And PNFS solves a lot of those issues. So, the challenge obviously right now is it's not widely supported on the client side. We're just beginning to see its support in Linux. It's not obviously supported in Windows. It's not supported in VMware yet. So I think to the extent that the client side of that becomes better supported, you're going to see more storage systems, especially the scale-out storage systems, add support for it.
Once you have, oh, sorry, go ahead.
These are my political questions.
Good
I don't think
questions.
so.
No, you've got a,
I have a few more. So you talked about, traditional storage arrays having this concept of partitioning out their drives, whatever. So you're saying the larger flash array, with flash arrays, that you don't need to partition it that well. So what, when you talk about supporting, if there have been fiber channel, Isakovich, NFS, whatever, what I didn't hear any talk about was LUN or file system sizes. I mean, if I send the 16-byte SCSI command to you, to be able to handle it, what is the maximum size of your NFS file system?
so it sounds like you're wanting a bit more detail, a bit more technical detail around that sort of thing. So who wants to take that
Well,
first?
it's a short answer. It's 4 exabytes in our design single file system, single file up to a petabyte, single file system 4 exabytes.
One of the interesting things I think is you see, coming from like a converged architectural perspective, the protocol differentiation seemed to matter a little bit less. So example, like our storage platform supports NFS, CIF, Samba stuff, and iSCSI in that, primarily for those smaller companies. We don't do fiber channel or no IB or anything like that. But we don't use any of those protocols to talk directly to the effectively object store that we're talking to on the back end. It looks like a directly attached file system to the nodes in the cluster. So we actually circumvent all that file system stuff, all the protocol stuff. And it basically, that's one of those inherent pieces that makes the converged infrastructure piece a lot more simple than going in with the other breed solutions, because you got to have the protocols that are going to specifically be able to interoperate and have those different components talk together. So I think one of the interesting things you will see from convergence over the next few years is actually kind of the elimination of some of the protocols, making effectively that style of deployment something that's simpler to deal with. And then from that perspective, you can have either some type of distributed object store or parallel file system on the back end that can actually get you all of the advantages of the performance improvements you can get from PNFS, but it could just be like a different clustered file system on the back end.
Yeah, that's fine for the back end, but
Yeah.
the front end is what the host is concerned
Well, but when the virtual machines are on basically that front end and back end, then that's basically just how they are interfacing to get to their.
Right, but the size of the object is what's important. How big of the MFS can you
Yeah.
have? How big of the MDK can you have? How big of the NFS data store can you have?
Yeah.
What's
So-
the addressable size? And
So, I think it's interesting because I would kind of contrast our approach to that. We've taken a different approach, which is rather than say, okay, we have petabytes of capacity and we want to enable you to make it a single block device for your for your VMFS system, we've taken the approach that, look, it actually makes more sense as we look at the roadmap of where storage and virtualization are going to be able to support lots and lots of individually addressable volumes so that you can have a direct relationship between a virtual machine and the storage object that represents it, whether it's a file or a volume or something like that. And I think that certainly aligns well with some of the things that VMware is doing. So we don't support ridiculously large volumes because, again, it's a better use case for us to say an individual volume corresponds to an individual VM, and we can apply quality of service, we can apply isolation, we can apply security and replication and other features on a VM by VM basis rather than putting them in a giant bucket that we have no visibility of. And so I would say on the block side of things, we actually think that's more in line with where things are going rather than supporting a single block device that's a petabyte in size. On the file side, there's obviously need for large-scale single namespace file system, not really for VM storage, because I think there's other ways to deal with that, but certainly for big data and shared file applications, there's needs for that. PNFS, I think, helps make that a lot more reasonable than trying to do a single namespace through a NFS3 endpoint. But I also think object storage is going to dominate that space going forward, and scale out object-based storage systems that are capacity-oriented as opposed to performance-oriented will really do a much better job of handling those situations where, look, I need a petabyte of capacity or 2 petabytes or 20 petabytes in a single namespace. Object storage is frankly just better suited to that than a file and folder-oriented protocol.
Okay. So do you want to do one more question, then we'll move on, because we've got...
Yes, you understand object storage is coming eventually, it's not there now. And, with current releases of vSphere, we have storage, so the idea of larger storage works nicely, maybe. It becomes a matter of how big, what's the biggest chunk you can address on your site.
I think that whole vSphere storage support thing is probably something we could do a whole session on. And Stephen should try and add that to the conversation that goes on in your presentation that you're doing later, perhaps, and go back and revisit some of that, because clearly that's relevant then, I think, as well. But I'd just like to move on and maybe ask Robin a question, because we're down to the last sort of 4 minutes. And I'd really like to understand whether you think we're at an inflection point where the old style technology is going to fade away, and what we're really looking at is to take things forward. We have to put new technology in place, new designs, new infrastructure. And the reason I've started with you, Robin, is because clearly you're not a vendor. So you're not going to just say yes, obviously, if you don't think that's true.
Well, I just spent a little time talking about that, but it's pretty clear to me that the whole RAID-array model is in the process of breaking down. Now, it's a big business, right? I mean, people buy billions and billions of dollars of RAID arrays every year. And I remember when RAID first came out back, roughly 1990, and it took something like 8 years before half of the capacity that enterprises were buying was RAID capacity, as opposed to just individual disks that were being mirrored. So we're dealing with a tremendously conservative customer base. And so I think it's pretty clear, though, that you're not seeing hot new startups building new RAID arrays, using disks. Okay, you've got hot RAID arrays that are using flash. So we're definitely heading towards an inflection point. Is it going to take 8 years? I don't think so. I really think that the pressure created by Google and Amazon on corporate IT infrastructure costs is going to force people to move a lot more quickly than they have in the past.
Okay, thanks. So I think we've only got a couple of minutes left, so perhaps we can just go through the remainder of the panel and maybe wrap up, give us your view of what we just discussed in the summary.
Yeah, I'll just build off of Robin's comment in the sense that one thing that really surprised me about our business as we went in, I really expected that people would only look at flash that needed a high level of performance. That was their driving goal. And it would basically be driven by large banks, telcos, your traditional early adopters. And so if I look at our customer base, 3 years in now, we've got some of those largest banks on Wall Street, largest web customers, et cetera. But we have a very healthy business in kind of what I would consider very, very traditional storage buyers. People that were probably the salt of the earth buyers for the likes of EMC and NetApp over the years. And it's just become clear to them that it's no longer a good use of money to go out and buy that same old disk array again. Flash is a clearly superior technology. And I think we're just hitting this breakthrough moment where flash is being viewed as not something just for kind of those elite use cases, but really an every person storage technology. And so if there's anything that we try to do as market makers in this space, it's just open people's eyes up to the fact that if you hadn't thought about a flash array before, the time is really now. And as I think Robin said in his intro before, it's just the adoption rate seems much faster this time around, which is great for us.
All right, thanks, Tom.
Sure. Well, I think flash's time has definitely come. They're just applications that can't be done economically any other way. We just did a report with Evaluator Group where they actually did an assessment of a disk array versus a flash array and came to the conclusion that the flash array from Nimbus was about 1/5 the cost per virtual instance than the disk array. So that even though from a CapEx perspective there was a difference, from an actual load and usability perspective, the flash array from Nimbus was just so much more efficient that it was actually worked out to be dramatically less expensive. So you've got these use cases that just demand flash, and flash actually is the more economical option. I think the second thing too is that flash is being adopted by industry-leading companies, and those companies are getting a competitive advantage out of their infrastructure. The other companies that are not making those same decisions are not going to be competitively positioned as well. So as much as it took, for example, like a Fusion IO to sort of get a little bit of momentum around the PCIe concept, once it got hold, that thing is just blown out the door. And I think you're going to see the exact same thing here with network-attached flash or SAN-attached flash, such as our solutions. It becomes a competitive weapon that if you don't have, you're at a liability.
Okay, Dave, and bearing in mind we're actually over
Right.
time, so...
Look, I'll be quick. So I think, looking at the future of storage architectures, Flash is clearly great. Flash solves a lot of problems. But if you look solely at the benefits of Flash that Flash provides out of the box, hey, great performance, low power utilization, fantastic density, you're missing a lot of what can happen when you build entirely new storage architectures on top of Flash. And in our case, we've really found ways to leverage Flash as a building block for an entirely new set of functionality that just hasn't been possible before on architectures built on disk. Things like the ability to guarantee SLAs to thousands of virtual machines in terms of their performance. Things like the ability to scale and move performance across petabytes of capacity, millions of IOPS. All different things that when you take a step beyond the kind of native characteristics of Flash, you can do some really interesting things with it as a next step.
Okay, and Jason, you've literally got like...
It's seconds here. It's like,
you haven't even any time.
yeah, what those guys said.
Yeah.
Okay, so I think
Okay.
scale out is very interesting. Flash is a very interesting piece, and when the applications really are developed to really start taking advantage of that, that's when you're going to see really rapid adoption and movement in that space.
All right, okay. Well, thanks everybody. Thanks for that. And I think we're going to get chased off the stage, and I hope that was of use to everybody. Thank you.